Hello student, in this video we are going to introduce time domain analysis or time response analysis. This time domain analysis or time response analysis is very important in control system topic. Why? Because this is important. Whatever the signal we are going to consider in time response analysis or time domain analysis, there varies with time. So here, whatever the signal you are considering like RT as a reference signal or input and CT is our control output. So all those you are taking with respect to time. So that's why this time domain analysis or time response analysis is very important in control system. Okay. Then what is meant by this time response analysis? The response is nothing but output of the system. So time response analysis is nothing but variation of output of the system with respect to time is called as time response analysis. That means, so if time is varying, so with the time, what is the variation of output of a system? Okay. So that means we need to see the variation of output CT. So that is called time response analysis. With this time response analysis, we can study the stability of a system, the accuracy of a system. So we can study the system by using this time response analysis. So this is very important throughout the control system. Okay. So how we can calculate this time response? Time response is nothing but output with respect to time. So up to now we discussed about output in terms of transform. That means we consider as frequency domain. Frequency domain of the output up to now we consider in our previous video to calculate our transfer function and gain. Okay. So that means you consider C of S. But here in time response analysis, you are going to calculate your output with respect to time. That is meant by output in terms of time. That is CT. And you are going to calculate CT. You are going to calculate output in terms of time. Okay. So here I am going to consider a control system like if we consider a closed loop control system, then if RS is input and CS is the output of this closed loop control system, then normal negative feedback closed loop control system, then what is the transfer function? Transfer function is CS by RS equal to GS into 1 plus GS into HS. Okay. This is the transfer function of simple negative feedback closed loop control system. Okay. So this is the transfer function of negative feedback closed loop control system. Okay. So for example, if we want to do time response analysis for this system, okay, you need to find out the output. So now we will find out the output. How you will find out the output? You will find out the time response analysis means you need to get the output with respect to time. Okay. that means you need to get CT, not CS. Okay, you need to get CT. So here you know that from the knowledge of negative feedback of the system, negative feedback closed loop control system, the transfer function is this. Okay, CS by RS divided by GS into 1 plus GS into HS. Okay, so by this we can write, from this equation we can write CS equal to RS into GS divided by 1 plus GS HS. So ultimately to get the time response, so how we will get this time response? So time response means output with respect to time. That means you need to get CT. So further take inverse Laplace transform of this. That means, so see, this is the output means transfer function of negative feedback closed loop control system. Okay, if we write CS, then this CS equal to RS into GS divided by 1 plus GSHS. Okay, so this is output transform of this negative feedback closed loop control system. So from this, how we will get time response analysis? Because in time response analysis, the output varies with respect to time. So for this, that means we want to get CT. So for this we are doing inverse Laplace transform on both sides of this CS. Okay, so after inverse Laplace transform, CS is CT and this CT is equivalent to inverse Laplace transform, and within third bracket RS into GS divided by 1 plus GS HS. Okay, so like this way we will get time response of the system. Okay, so in time domain analysis, you see, in time domain analysis the response of a dynamic system to an input is expressed as a function of time. Okay, it is possible to compute the time response of a system if the nature of input and the mathematical model of the system are known. Okay, usually the input signal to control system are not known fully ahead of time. Okay, it is therefore difficult to express the actual input signal mathematically by simple equation. So now coming to types of response, time response analysis. Okay, so here we are having two types of time response analysis. Okay, first one is transient response, second one is steady state response. Okay, so transient response is nothing but the response of the system which would varies with time. Okay, so here up to this is transient response. Okay, so transient response is nothing but the response of the system which would varies with time. So coming to steady state response, so steady state response of a system won't coming to the steady state response, so steady state response of a system won't change with time. It will come constantly. So this portion is steady state response. This is transient represented by TR and this is steady state response represented by SR. Okay, so steady state response of a system won't change with time. Okay, it will come constantly. So for example, if you are having any response CT like this, okay, response CT like this, CT like this is T, means x-axis represent t, and y-axis we are going to consider ct. Means this is t, okay, and y-axis is represent ct. Ct means output, okay. So if your response like this, so up to here means this, up to here it is varying from here to here, it is varying from here to here. See, it is varying from up to here, it is varying from here to here with respect to time, okay. So up to here it is varying from here to here, and this is, and this part is constant, okay. So this is called as transient response, means this is called as transient response, and this is called as steady state response of the system, okay. So here we have studied two types of response. One is transient response, which vary with time, and another one is steady state response, which won't vary with time. As name indicates, it will have a steady value like this, and this is the introduction of time domain analysis or time response analysis. So today I will stop here. I will continue this topic in the next lecture.